Okay, so we're going to prove the converse of the midline theorem. So a midline of a triangle is parallel to the third side and is equal to half its magnitude. So if D is the midpoint of AC and E is the midpoint of BC, aka the midline, right? Then AB is parallel to DE and DE is equal to half of AB. All right, so let's go ahead and do this proof. Okay, so we know that D is the midpoint of AC. So this implies that AC is equal to 2 DC, right? Similarly, E is the midpoint of BC. This implies that BC is equal to 2 EC. All right, so now I know that angle C is in both triangles. So I have this side proportional to this side, and I have this side proportional to this side, and the angle in between them is congruent. So I can go ahead and write that. AC over DC is equal to AC is 2 DC over DC, which is equal to 2, right? They share that same proportion of 2. And similarly, BC over EC is equal to 2 EC over EC, which is equal to 2, right? They share that same proportion. And I know that angle C is congruent in both triangle ABC and DEC because it's the same angle. So this implies, by side angle side similarity theorem, that triangle ABC is similar to triangle DEC. And if they're both similar, this means that all the corresponding angles are congruent, right? So that means that this angle is congruent to this angle, right? And let me get another, let's do purple. This angle is congruent to this angle. So I can write angle BAC is congruent to angle BAC EDC, and right, and I know that angle let's see, ABC is congruent to angle DEC. Also, I know that DE, I know that AB over DE shares that same proportion of 2, right? And I know that AB over DE, so AB over DE is equal to 2 because the rest of these are equal to 2, right? All right, so now that these two angles are congruent, that means BC acts as a transversal for line AB and DE, and we know since these two are congruent, then that means AB must be parallel to DE, right? We could use the same argument for since angle A is congruent to this angle here, right? Angle BAC is congruent to angle EDC, then these two lines are also parallel. So I'll just put both, right? So I have angle BAC is congruent to angle EDC, and angle ABC is congruent to angle DEC, right? Both of these together by the corresponding angle postulate implies that AB, right? That implies that AB is parallel to DE, which is half of what we wanted, right? And then let's do the other half. We have this equation AB over DE is equal to 2. So if I multiply both sides by DE, I get AB is equal to 2DE. And then I can divide both sides by 2 to get 1/2 AB is equal to DE, which is exactly what I wanted, right? And that is the proof.